How can planning data be exchanged digitally? With the new automation markup language standard, we now have the ability to flexibly transfer planning data between different systems. The challenge during the planning phase is using different systems. Hardware configuration, electrical planning, and engineering require different systems, in which we create the same basic information again and again. The standardized transfer of this basic information across all three of these systems would represent enormous added value. One option for exchanging this basic information is provided by the automation markup language, and we have already implemented this function in our software tools for both hardware configuration and engineering. We'll show you how we can exchange planning data across systems in an optimum way, using the automation markup language in an example.
For our example, we'll use the Digi-Demo machine, and I'll show you how we end up with a complete Digi-Demo machine in the example. The machine consists of the heart of automation, an S7-1500 controller, as well as a CTOP 8600 power supply and decentralized peripherals such as an ET200AL module. For the first step of hardware selection and configuration, we'll begin with the TIA selection tool. I've already begun with hardware selection and configuration in the TIA selection tool, which is available free of charge. We can see our S7-1500 CPU and the decentralized ET200AL module peripheral, and now I'll add the power supply. The TIA selection tool helps me to select the right power supply using smart assistants. Using the corresponding menu, I can click through the relevant power supplies and select an appropriate one for the current configuration. I can then supplement this power supply with subcomponents as well. For example, I can supplement the system modules here simply by double-clicking them. With this, I've completed my hardware selection in the TIA selection tool and can transfer the data to another system. To do this, we'll export the data in the automation markup language format by first selecting our ECAD system as the target platform and then selecting the storage location on our hard drive, generating an automation markup language file in the process. We'll use this automation markup language file to import it into another system. We'll use ePlan Electric P8, version 2.7 or higher, for the electrical planning here. Now I'll import the AML file using the corresponding menu item and can begin drawing my schematic with it. I'll start with the rack setup by dragging individual components to the schematic, beginning with the S7-1500. This will be followed by the AL and its corresponding input and output modules. On another page of the schematic, I can also make the network configuration. To do this, I'll use the CPU and AL once again, and can now interconnect the individual ports to one another using the ePlan connection tools here. In the next step, I'll configure the individual network ports. By double-clicking a port, I open up the dialog box, which I can now use to save the corresponding data. The configuration project network name, bus master and IP address are required here. The CPU will function as the master in this network. I'll select the corresponding checkbox for this. Then I'll configure the port of the AL group. Here I'll use the same configuration once again. Using the same network name and the same I/O system, and issue an IP address which is still available on the subnet. It's possible to further enhance the data, for example by creating input and output symbols, but I'd like to leave it the way it is. In the next step, I'll transfer the data to the next target system. Once again, we'll export the data in the automation markup language format using the corresponding menu item, and can then continue in our TIA portal in the engineering framework for automation. In the TIA portal, we can once again import our planning data using the corresponding menu item. To do this, we'll select the generated AML file from ePlan and can now see how this generation creates the hardware in the project accordingly. Our hardware has now been created, including the network and optional I/O symbols. Once we've finished hardware planning, we only need to supplement the user program and can then commission the system.
As you've seen with this example, the consistency of the data is ensured through all three planning steps. Importing and exporting the basic data also saves us an enormous amount of time. And we have full flexibility to connect additional systems, thanks to the Open Automation Markup Language standard.
Siemens. Ingenuity for life.